we're going to be able to model exponential equations and solve them using logarithms. So a lot of, more of the same of what we've already been doing. So let's take a look. All right, so there's our power to a power property. That's what we've been using all along, right? If you see, this is a power, because logarithms are exponents, right? So this is a power to a power. So it's actually, so if this is an exponent here, and it's being raised to an exponent, normally we use the product property, correct? So we're going to do the same thing. We're going to bring it out in front because we say, look, they're both exponents, right? That's what we use logarithms for. We turn them into exponents. Your b is your base. All right. So similarly, if you see an e, you can do the same thing. So we were just going over. If I see this as an exponent, I can bring it out in front and make it multiplying. Or it can be behind, right? Does it matter? No, right? I can put it in front, I can put it behind, doesn't really matter. Okay, let's look at these. So you've already done this one, right? When interest is accrued once a year. So we did this with Miss, you guys did this with Miss Witt, right? So you guys did this really good on your test. You guys did a fantastic job. The quiz. Yes. Was it a group quiz? Yes. Okay. This one is very, very similar. The only difference between it, and it should have a plus or a minus sign in here. The only difference is it's got this n and this n. Okay? So what happens here, it wouldn't be minus, it would just be plus. We're talking about interest. Okay, when interest is accrued more than once a year, so what do you think this n stands for? The number of times we're going to accrue interest, okay? And t is the same, right? The only addition, can you guys see that? The only addition is I'm going to take the rate and I'm going to split it so many times during the year. So if I said I was going to accrue interest twice a year, that number would be a 2. If I said I would accrue interest, here's a vocabulary word, quarterly, how many times is that in a year? 4. If you break your year into quarters, you have 4 of them. What about if I want to do it monthly? 12. So this number would be 12, that number would be 12. So everything you already did with Miss Wiz is the same, except for if there's something in the problem that talks about compounding more than once a year. Kane. Exactly. So if we're talking 4 years, and every year you're doing it quarterly, exactly. But we're going to do more examples of that. And then there's this one. This one's very similar to this. All of them have, right here, A is my initial amount, right? P is my principal that I start with, which is also initial amount, right? And here I have P, which is my principal or the initial amount. So they all have that out in front. These two are very similar because they're talking about taking a whole and adding the rate to it, taking a whole and adding a rate to it, broken up into however many pieces. This one is just simple because it's just E. And this is when we have interest accrued continuously. So here's your continuous, we use the E, right? That means it's happening at such a fast rate that we don't even know what to do with it. We can't compute it. Does that make sense? So we'll have, can you guys think of something that would happen in such a fast rate that we wouldn't even be able to say how many times it was happening? You know what? That's a hard one, population growth, because sometimes we use this one and sometimes we use that one. But something like how bacteria grows, right? Something like that. Things that are scientific, you usually get this. You'll see this word continuously. So when we see continuously, we use E. When we see something talking about happening more than once a year, we use this middle one. And then all the other ones, we use this one. Okay? All right. Christiana. Well, we're going to do some examples, and I think it's going to become really, really evident pretty quickly which one of these you're going to use. And you don't have to memorize them. Yeah?
So is that E a variable or is it pi?
It is E like the pi is. Yeah. It is its own special number. It's 2.71. Just like pi is 3.14. It's its own unique number. Okay? Alrighty. Yes. Yes. There's no difference. One of them just stands for principal, and one of them is initial amount. But those two things are the same. Okay. All right, so we actually did all these problems already. Okay, you did them in your homework where you had to come up with the graph, and then you had a constant line. Remember that? And you found out where they met. Remember that homework problem? Those homework problems? Okay, so now we're going to actually solve them with logs. All right, so it says Tony purchased a signed baseball in the year 2000 for $3. So $3 is his initial amount. Experts estimate that its value will increase by 10%. That's where our 1.10 comes from per year. The value of an item over time in years can be modeled by this equation, which is what we did here, where A is the initial value of the item and R represents the rate of increase. Okay, so it says use a graph to find the number of years it will take for the value of the baseball to be $20. Well, that would be $20 would be, if this is 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10, so $20 would be here. This is how we found before. So we estimated. Sorry. We estimated. And we would go down here and we would say after how many years? About 20 years. We would say about 20 years. Well, now I can write myself an equation and solve this. Correct? What would you do first? Bryce, what would you do first? Divide what? By what? I'm just going to get rid of my 3. Okay? Okay. So I'm going to divide both sides by 3. Do you see how once I set this up, it's exactly like last night's homework? It's the same thing. We're going to do the same thing today. So all you really need to do is figure out, is practice what you should have been doing over the weekend, right? Practicing that, and then practicing putting things in your calculator. So the only new learning here is going to be figuring out which equations to use. Okay? And so we'll go through a few different examples. So now I have 20 divided by 3 that I need to put in a calculator, but I'm not going to yet. 20 divided by 3 is equal to 1.1 to the t. Obviously, I don't have common bases, so what do I need to do? Log both sides. So I'm not going to skip any steps on these. So I'm going to log y. Log 20 divided by 3, and I'm going to log 1.1 to the t. Right? Better? Now you can see what I did on both sides? All right. Now what? Nope. Why did we log both sides? I can't find a common base, so I need to do something with this exponent. That is why we log both sides, because I need to do something with that exponent. I can't solve for it while it's up there, because now I can move it, right? So that's what I'm going to do. I'm going to move it. All right, I'm going to let you guys write this down in just 1 second. So now I have log 20 over 3 equals t times log 1.1. So what's my final step? Divide by log 1.1. How do I want to write this? I can see how the notes would be confusing when you have multiple steps in front of each one. So I'm trying to redo each step nice and easy. And now I just put that in a calculator. So now I have t is equal to log 20 divided by 3 divided by log 1.1. Put it in the calculator, let's figure it out. Yes, Kane. Where would you put the t out front? It doesn't change it, but technically you can't bring it out front until you've logged both sides. So I get that you can process that in your head, but technically you can't do that rule until there's a log on both sides. Yeah, I would. Is that what everybody got? How do I know that's a reasonable answer? 19 point what? 19.9? And that makes total sense since we estimated with our graph it was going to be about 20 years, right? So it's 19.9 years. All right, do you guys want to write these steps out? Would you like to write them out? What? In your notes? I mean, it's totally up to you. Yes. Yes. Phone away. I can. I'm just waiting. Can I go up now, guys? The other way this way? Okay, here's my problem with notes. And so we have to solve this. There are 3 people taking notes in this class right now. So everybody else is just sitting here. Scroll up where? This way? Are we good? Well, not everybody, since there's 3 people doing it. Like, I just need to know, can we just take a picture of it, and then you guys can copy it? Okay. So if you need this page, then take a picture of this. And then when you guys are ready for the next one, I'll scroll all the way up past this step here. You're very welcome. And then this is the next step. All right. I think on the next problem, we'll do it less of the long steps, and I'll write out what we're doing in each one. How about that? Yes.
So before we go to lunch, you're gonna do like the time for the time, or you do it
What time is lunch?
after the time goes,
Thank you.
That's good. Never mind, I didn't know we had that late. That way.
Okay, ready? Okay. So here we go. So I'm not even going to read it. Are we okay with that? Okay. So I want to estimate how long, I want to not predict, but after how many years will the value of the truck be 5,000? So I'm going to write this 5,000 equals 28,000 times 0.905 to the t. So the first thing I need to do is I need to divide both sides. We're going to cover this up. There we go. Now it won't do that. So the first thing I need to do is divide both sides. Divide both sides by 28,000. Bryce, what is so funny? Okay, let's not. All right, so now we're left with 0.905 to the t. I can't do anything with that, right? So what do I do next? Log both sides. I meant to change the color on that. So I'm going to log both sides. Yes, sir. When we have E, we use ln. That's the only difference. ln is only used when you have E. That's it. That's the, exactly. So log both sides. So now that I have a log on both sides, I can, now, that's the whole point of this, I can move, why does it keep doing that to me? I can now move t out front, right, and make this a multiplication problem. So the next thing I needed to do was move the exponent. Now I have log 5,000 over 28,000 is equal to t times log 0.905. So what's the last thing I need to do? Divide both sides by log 0.905. I'm just going to copy this. I don't even know what just happened. No idea. Okay, so can you guys guess what I don't like about this part of logs. It's just so dry, right? You guys are bored out of your minds right now. It's so boring. It's boring to teach, and it's boring to learn, right? I don't care. It's the truth. Anybody watching this video right now is like, yes, this is so boring. Oh my gosh, it's painful. Professes her hate for logarithms, right? Okay, do you guys want to take a picture of this? No. Okay, next. You ready? So we will come back from lunch and we will do a little bit of this homework, right? New homework. And then we'll do, I don't know, we're probably, Bryce, I didn't ask you what you wanted me to do, right? Then we'll decide how much further we're going to go, because we need to get to the test this week, right? Okay, have a great day, guys. I'm not going to be here, and I think Miss Liz is going to go down to lunch.